Hello everyone. Today I'm going to quickly show you two examples on 6.6 on the modeling with the trig functions. Okay, so if you have your worksheet with you, I want you to look at example number 1, where there's a ladybug is sitting on a wheel 6m in radius, which rotates at 3 revolutions per minute, and the wheel is located 2m above the ground. So we need to draw the graph showing two complete cycles, and then we have to write an equation showing that the bug's height of the ground as a sine or cosine functions of the time. So we already know the techniques of how to sketch a sine or cosine functions, but when it comes to the modeling, we have to make sure that we read the questions carefully. Like I would suggest that you read it twice, and then make notes of all the details that is given, okay, before you start to do your graph. So basically, with the information that is given, the radius of the wheel, okay, because the ladybug is sitting on the wheel, 6m in radius, so we already know that the radius must be 6m. And it also rotates, 3 revolutions per minute. So 3 revolutions per minute. And it is located as 2 meters above ground. So we have to make notes of all of this. Okay? So once we make notes of all of this, then I can start putting those informations on the graph. And the graph is basically the bug's height as a functions of time. So on the graph, as you can see, I will be using the y-axis as the height in meters. So you always label the graph instead of x and a y. Now with the modeling, with all these word problems, we have to make sure that you don't use x and y's anymore, okay? If you keep using x and y, that will cause you some deductions, all right? So because the height depends on the time, so we pretty much have the x-axis labeling as the time in seconds, and the y will be now a height in meters, okay? And with the given information, since we know that the radius of the wheel is 6m, then the amplitude, okay, if we're going to model this with the trig functions, whether it's sine or cosine, we know that the amplitude doesn't change. The amplitude really it represents the radius of these circular objects. Now, in terms of the period, well, because the period that it rotates 3 revolutions for every minute, okay? So we can certainly determine the periods in terms of second. If this is not in second, then I can just put that as my period. But because I want to convert everything in terms of second, so I have to do a little calculations here. So think about if 3 revolutions will be in 1 minute, which is 60 seconds. Okay, if I set an equivalent fractions of 1 revolutions and how many seconds, okay? So cross multiply, so you can solve for the x as 60 times the 1 and then divided by 3. And then you will see the time in second per revolution. So this is going to give you 20 seconds per revolutions. Okay, so why is this important? Well, now we know that every 1 rotation or 1 revolutions, that is 1 cycle, that is the period. Okay, so I can now say that the period is 20 seconds. Every 20 seconds, the wheel is going to go 1 rotation. Okay, so now we know that the period is going to be 20 seconds. So once we know the period, so same thing on the graph, every period will have 4 equal parts. So key point is happen every quarter of it. And we always take the periods, 20 seconds, okay, divided by 4. So that means a key point is going to happen every 5 seconds. Okay, key point happens every 5 seconds. Now, when it comes to the max and the min, then think about the other information that we know, that the ladybug is sitting 2 meters above ground. So that pretty much is the lowest. Okay, is the lowest points that this ladybug is going to happen. So we know that the 2 meters here, this has to be the minimum. Okay, so I want to bring it to show it to you here. So if this is the minimum, because the wheel, sorry, it's not the ladybug, it's the wheel is located 2 meters above ground. Okay, you can also see that from the other diagram, that you know how they give you like 2 meters and before you start to see the wheel. Okay, and the ladybug actually is sitting right here. Okay, where I put the cross, this is where the ladybug is sitting, and it has a radius of a 6m there. Okay, so because the minimum we know that is in 2 meters above ground, the x-axis represent the ground level. Then when you add the amplitude 6, then you know that my middle point is going to be at 8m. Okay, and then adding another 6, then that will give me a maximum of the 14. Okay, so right now, right here, I can put in the informations about a 2m here, but the maximum is going to be a 4m. And right away, we know that the C, the equations of axis, okay, and I can certainly put in the equations of axis. The middle line is going to be height is equal to 8m. Okay, so it's not y anymore, but now it's the height equal to 8m. Okay, so I can certainly very quickly give myself this broken line on the graph showing that h is equal to 8m as your equation of axis. Okay, and now we could give ourselves two different trig functions to represent the scenario. However, if you look at the diagram of where the ladybug is sitting, it actually gives us also the indication that the ladybug is sitting right on the middle line. So it's not down here, it's not up here, but it's sitting in the middle line. So I can assume that the ladybug initial position, it should be there at 0, 8. Okay, so the starting point, okay, I can also give myself another information that the starting point is going to be equal to 0 time, so when it's the initial time and at the height of 8. Okay, so this is where I'm going to plot the starting point. So knowing that every 5 seconds is going to give me the first quarter of the cycle, so that means starting from here, when it comes to the 5 seconds, okay, I'll get my first key points up here, okay, at the maximum. And the other 5 seconds, so up to 10 here, I'm back to the middle line, and another 5, so at the 15, I'm down to the minimum, and another 5 seconds, 20, I'm back to the middle line. Okay, so I pretty much I can connect this, okay, this graph. Okay, that goes like this. So this is the one cycle. So one cycle, it will be 20 seconds. Okay, and of course, this graph, this question will require you to do 2 cycles. So I let you finish the other cycle. But this first cycle, assuming that the ladybug is sitting at the middle according to the diagram, so this will be my first cycle of the graph. Okay, you can continue with the second cycles on your own. So based on this graph here, okay, based on this graph, then I can certainly give myself an equation in terms of sine. Okay, so since the amplitude here is a 6, and I'm starting assuming that with the indication that the ladybug is going up to the maximum first, so therefore we should be having an amplitude of 6. Okay. Sorry. Let me just rewrite this again, because I have to give myself an equation in terms of the height and the time. So the equations will be h of x, okay? Well, maybe to be more specific, is the h functions, the height function in terms of time, is going to be equal to, the amplitude is 6, okay? And so this is a sine function, so I should have a sine, okay? Now, what is the k value? Well, I know that the period is 20 seconds. And I hope everybody still remember the to get the k value, okay? We are going to use the same formula. Is pretty much that is the, so we take the k equal to 2 pints, because the base functions of the sine always have the 2 pints, right? And divided by the period, and the period is 20 seconds, okay? So when you reduce that, you know that your k value is going to be pi over 10, okay? So this is what you are going to have. So here you have a pi over 10 as your k value, okay? And well, times the x, but now the x is the t, since there's no phase shift in this case, because it's starting along the y-axis, that means there's no phase shift, okay? And then plus the c value, and the c value will be the middle line, and the middle line now is a plus 8, okay? So this is what you have for a sine functions that model this questions here, okay? So you have an amplitude of a 6, sine functions of a pi over 10 times the t plus the 8, okay? And again, if you look at the k value here, if you follow the formulas for the periods, where the you always take the 2 pints over k, and then you should be able to get 20 from there. But the k, in order to find the k values, knowing what the period is, we use the same or similar formula, because when you solve for k, you still get the 2 pi divided by the period. So that is where I'm getting the k values from, okay? Now, when it comes to the cosine, so that will be easy, because the cosine will be, you can probably give yourself a cosine functions by choosing a different starting point, okay? So let's say if the cosine, if I'm choosing this as my starting point, like the maximum, okay? Up here, if I'm using this as my starting point, then for the same functions, I'm going to have, again, it's a h functions bracket t, okay, The amplitude will not change, so you still have an amplitude of 6, okay? But now, because you are giving yourself a cosine function, so you have a cosine, and now the k value is going to be the same, okay, because the period doesn't change, okay, even though this is going to be continuous. So the k value is still a pi over 10, unchanged. But now, because you have chosen this as your starting point, that means you do have a phase shift now of a 5 second. So therefore, you need to have a bracket t, and it's a minus because the phase shift is 5 seconds to the right, okay, minus 5, okay? And then the middle line doesn't change. The equation of axis doesn't change, so it's plus 8. So now if you want to give me a cosine function to model this questions, now you should have a 6 as the amplitude cosine, brackets of the same k, because the period doesn't change, so pi over 10, but bracket t minus 5, because now you have a phase shift of a 5 second if you choose this as your starting point. So it depends on your starting point. Some people might want to choose this as your starting point. If you are going to choose this as your starting point, then you're going to have a phase shift of a 15 seconds to the right. So the only difference you're going to give yourself is a t minus a 15 over there instead of t minus 5, okay? But obviously, we always want to use the function that model this without the phase shift whenever it's possible. So I would use a sine function to represent this because the sine functions will not give us any phase shift, okay? So continue on the next example, okay? The next example is about a Ferris wheel, a very popular type of word problems, has a diameter of 18 m, okay? So when a diameter of a Ferris wheel is 18, that means the radius is going to be half of it. So half of 18 is 9. So right away, I know that the radius is going to be 9m, and that also will give me the indication that the amplitude is also 9m down here. So you can also write this right away, okay? It rotates 4 revolutions per minute. So it rotates 4 revolutions per minute. So again, on the graph, usually we don't take the scale for the time as a minute. So on the graph, as you can see, I already marked this in terms of second. It usually is better with seconds, so I don't have to give myself some scale that is in decimal, like in fractions. Okay, so that is the reason why I usually will turn this into second. So if you have a 4 revolutions per minute means 60 seconds, setting yourself into a 1 revolutions with some x seconds, so now you can solve for the x, and therefore you can solve that x is equal to 60 seconds divided by 4, so that will give you a period of 15 seconds. So every 15 seconds, so that means 1 revolution would take 15 seconds. So the period here is at 15 seconds, okay? And because period is 15 seconds, then the key points is going to happen every 15 divided by 4, okay? So it happens every 15 divided by 4, so it's going to be a decimal of approximately, or this is equal to 3.75 second, okay? So on the scale, you are going to give yourself, okay, well, again, you will have 4 equal parts, okay? Yes, you will be sketching two cycles of it, but in my example, I'm only going to show you one cycle first, okay, and then you can complete the other cycle accordingly. So down here, because this is in a decimal, so you can also give yourself a decimal scale here. So you will have a 7.7, 3.75 or 15 over 4. And then this will give you, adding another 3.75, that will give you 7.5. And this will be a 16.25. And lastly is going to be the 15 second. Okay, so because when you take 15 divided by 4, you will get those in decimal. Okay, it's okay if you give me in decimal times. Okay, as long as this is not a non-ending decimal. So this kind of decimal is quite okay. But if you want, you can also give me like a 14 over 4 here, and then the fractions for the rest. But I don't think it's necessary since you are going to use the calculators anyway, right? And also, the rider gets on the height of a 1 minute at when the time is 0. So think about when the passenger will always get off on the wheel, on the Ferris wheel, a little bit above ground level. So they probably take a couple steps before they can sit on it. So we know that the minimum height of the Ferris wheel is going to be in 1m. Okay, and because the amplitude is 9, adding 9 with the 1, then you will get a 10 here as your equation of axis. Okay, because from the minimum, when you add the amplitude, you're going to get, so let me just write here, the equations of axis. Okay, so the equation of axis is going to be equal to height equal to 10m. Okay, so so this is going to be my equation of axis, h equal to 10. Okay, and the maximum is when you're adding the amplitude 9 with the 10, so you are going to get into a 19 meters as your maximum. So I'm going to write 19 meters down here as well. Okay, now if we have the assumptions that the passenger will get onto the wheels at the bottom, so that means the starting point. Okay, so the start point, I'm going to get into, let me just write it up here. So start point is going to be equal to 0 and 1. Okay, assuming that the passenger is going to get onto the wheel from here, right here at this point. Okay, so now we can start modeling or come up with the graph that the first quarter at 3.75, when the time 3.75 second, then the passenger is going to get up to the middle line right here. Okay, starting from here. So first quarter go up to here. Second quarter at 7.5 seconds, this person is, or the wheel is going to bring up to the maximum. And the next quarter, the third quarter, 16.25 seconds, and it's going to back to the middle line. And the last quarter at the 15 seconds, the wheel or the height of that person's will come down to at the minimum. Okay, so slowly you're going to connect all this point with the graph that goes like this. And this certainly, because the starting point is at the minimum, okay, since the starting point is at the minimum, therefore we're not going to use the sine graph. So in this case, I will give myself a graph, okay, height function in terms of time, okay, that will have the amplitude of a 9, but it's a negative 9. Why negative 9? Because I'm starting at the bottom and I'm going to use a cosine function because I'm starting at the minimum and only the cosine function start either the max or the min. But if you have a negative amplitude, then that will be the indication that you should have a negative in front of the amplitude. Okay, so it's a negative 9 cos, and the period. Okay, so since the period is so let's go back to where we have the period here. The period is the 15 second. So that means if I want to find the k value, so the k is going to be equal to 2 pi over the 15, the period. And since I don't have anything to reduce, so the k value is going to be a 2 pi over 15. So over here, I'm going to continue with my cos of the k value is 2 pi over 15 and times the t, because there's no phase shift. So I can just multiply with the t, okay? And then of course the c values, the middle line is plus 10. Okay, now some people might want to put the brackets here even though there's no phase shift, which is okay. I mean, as long as you don't get mixed up that the 10 is always away, is not part of the angle. The angle is always the 2 pi over 15t, or if you have a phase shift, then all of this will be part of the angle, but the c value, the equation of axis, is always outside. Okay, now of course I can give myself a sine function as well, okay, by choosing a point that is on the middle line. Okay, let's say if I choose this one as my starting point, I usually pick a point that is closer to the y-axis. Then I can also give myself a sine functions, okay? But now the amplitude won't change. It's still the 9. But because starting from here, I go up to the max, so that means my amplitude has to be a positive. So I will leave it as a positive 9 sine, and with the same k values, 2 pi over 15, okay? But now I have a phase shift of a 3.75, and the 3.75 is the same as 15 over 4. So I have a t minus a 15 over 4 as the phase shift to the right. That's why it's minus, and then plus 10. Okay? If you still want to keep the negative 9 of the sign, then you probably will have to pick this as your starting point. But usually we don't want to deal with the negative if we don't have to. Okay? So this will be the graph for the example number 2. Now, the last part of the questions is asking, then estimate the time interval when the rider is above 13m. So this is the second part of the questions. And I just want to quickly show you guys that for this one here, you can choose any one of this, but usually I will pick the function that has no phase shift, because with the phase shift, the functions will be a little bit longer. So if I'm using the negative 9 cos of 2 pi over 15t plus the 10 as to represent this question, then we need to find out when the height is 13. What is the time? Because then once I know when the height is 13, it's somewhere here. Okay? So the height of 13 is somewhere here. Then according to the graph, I should be getting 2 different times that will be at this height. So in between this 2 time, then that is when the Ferris wheel that is above the 13m. Okay, so finding when the times that has the height of 13 is the crucial part. Okay, so in order to solve for that, I want to make sure that you understand that the function actually is not f of x, but this function here really is h bracket t that is equal to that, same as what I have over here. So when you know that the height is 13, then all you have to do is replace the height with 13, okay? And then you're going to solve for the time, okay? Remember, this is the exact same question that I gave it to you in our last meeting, that you're solving for the x-intercept. So this is exactly the same example that asking all of you to solve for the x-intercept or the 0, okay? Because you know the height, so you're going to replace the height with the 13, but you need to know the time, okay? If you look at the graph, you see that, oh, where is the time that when I hit the height is 13? So you will get 2 times. You know for sure that you're going to get 2 times, okay? So what you're going to do here is that you need to rearrange that, okay? So what I will be doing is that I will bring this negative term over, okay? So you will have a positive 9 cos 2 pi over 15t is equal to 10 minus the 13, okay? And then I'm going to get rid of the 9 on both sides by dividing. So cos of a 2 pi over 15t is going to be equal to, so that will give me a negative 3, but it's over 9. Okay? And from here I can continue with that, but I'm going to let something here. It's called, like, you can call this anything here. So I will be calling this as a theta, okay? So if you have a cos theta that's equal to a negative 1 over 3 after you reduce everything, okay? So that means I'm going to let theta is equal to that 2 pi over 15t. Okay, I replace exactly what 2 pi over 15t with the theta. So I know that I will solve this according to what I know. And you know that a cos theta that's equal to a negative always give you 2 quadrants. And this is going to be, if you look at this CAST, the CAST rules again, and you know that it's going to happen in quadrant 2 and quadrant 3. So this quadrant 2 and 3, cosine is going to be negative. Okay? So let's find out what is the related acute angle. So the related acute angle, you take the inverse of the cosine of the 1/3 only. Don't include the negative because I don't need to know. The related acute angle is always positive, okay? So think about that way. So that's why when I take the inverse of the cos, I don't need to include the negative sign. And then I will get into the approximate row, the approximate answer, because this is not a special angle. So I ended up with a 1.23 rad. Okay, if you use your calculator, change it to the radian mode, you will get a 1.23 rad. So you're going to get 2 angles. So the principal angles in quadrant 2 is going to be equal to a pi minus a 1.23 rad. So that will give you a 1.91 rad. Okay, in quadrant 2. And then theta is also equal to pi plus the 1.23, which will give you a 4.37 rad. Okay, so and now I'm running out of space, so I'm going to solve for the time over here a little bit. I'm just using this part of the space to do the rest. So since I have 2 theta, so theta 1 in quadrant 2 is equal to 1.91 rad in quadrant 2. So think about since I let theta is equal to 2 pi over 15t before. So now I know that I can bring back the 2 pi over 15t, okay, and set it equal to 1.91 rad. Okay, solving for the t, that means t is equal to 1.91 times the 15, the flip of the 15 over 2 pi. Okay, and adding everything, then you will get approximately of a 4.56. Okay, and this has to be in second. Okay, it does make sense if you look at the graph. 4.56 is a little bit over here, and that is where the first point where the graph or the wheel is reaching the height of 13. Okay, for the second part, the theta 2, that is equal to 4.37 rad in quadrant 3. Okay, but again, since the theta is equal to 2 pi over 15t, now you're setting it to 4.37, okay, rad. And solving for the t, then you have a 4.37 times the 15 over 2 pi. And you're going to get approximately 10.44 second. And you will see that, okay, maybe it's not very clear on my graph, but certainly the second point is going to be a little bit before the 16.25. So, okay, so when you have a accurate graph, then you can actually see that quite clearly. But those are the 2 times. Okay, so to answer that questions, then therefore, when the time is in between greater than 4.56 second and less than 10.44 seconds, that is when the height is greater than 13 m. Okay, and because it's greater, then that's the reason why I don't put an equal signs there. Okay, if the question is asking when the height is greater or equal to 13 m, then I would put the equal signs there. Okay, so that is how we're going to solve for the x-intercept or the time for this particular questions. Okay.